Hello everyone. So today we will see the matching pattern, how to search in files, how to use the user manual for commands using the command man, and then after we will see this sorting, how to sort a file. So in the beginning, we will start with some comments that we may need it later when we are typing our command. For example, the command vi is used, for example, to open or edit a file, which is how we will use it today. We just create vi, the name of the file. We will open it if it is already created, or if it is not there, if we type vi, the name of the new file that we want to create it will create a new one with the specified name and give us the hand to type or to enter something in this file. Now, after we create or we open this file and we type that we want to type in this file, to close, to save and quit, we will use the colon W, Q, or CC. So here, basically, we will use even the colon W to save and continue editing, or the WQ to save and quit and exit this command vi, or the colon Q exclamation mark to quit vi and do not save changes. But the main two lines here that we want to use today is line 1 and line 5. vi to open or to create new file and edit it, and the WQ to save and quit the command. Another command that we will use it today is the echo command. Is very famous command in Linux. So it is used to display a line of text on the standard output, usually the terminal, which is commonly used in shell scripts and terminal commands for printing messages, displaying variables, values, or creating simple outputs. Here, this command echo, sometimes we use it to display on the terminal or to put the output of this echo command into a file. For example, if we type echo hello world, then pipe and we redirect the output of this echo to the name of the file that we are specifying, we can put the hello world in another file. We will use it in a few minutes. Another command that is very helpful, which is the man command, is built-in manual for using Linux command. It allows users to view the reference manuals of a command or utility run in the terminal. So man is the short for manual page, which includes description for applicable options, flags, example, and other informative sections. This is, for example, you can use it for man ls or man grep that we want to see it today, or whatever command that you want to have more information about this command. This is the general comments that we may or we will need it today. Now, let's go to the second part, which is the grep. So grep is a command that searches through the input file for a specified pattern. When grep finds a match to the pattern, it will print the entire line to standard output. So the general structure for the command grep is grep. We specify if we have some option I, V, L, C, we will see these options. Then the pattern, what we want to have in this line, or when the grep command should print this line. For example, we want to have or we want to print all the lines that contains the word ABC. And then this is the pattern. So ABC will be the pattern. The input file names will be the files that we want to search on it, this command or this pattern. So as we said, grep has a variety of options that can execute a wide range of operations once a match is found. One of these options, which is I. So I means to ignore cases. So grep, if we type grep -I hello example.txt, I means we are ignoring the cases. We don't care if it is hello with lowercase or with capital cases. So, and the hello, so we are looking for the word hello. As we said, it doesn't matter if it is capital or lower cases. And we are looking for this pattern hello in the file example.txt. Another option, which is inverse the matching. When used, grep will print out lines that do not match the pattern. So it will look for the pattern, then print the lines that doesn't contain this pattern. So grep-v hello example.txt will print every line in this file example.txt that does not contain the word hello. Another option, which is -e, and we specify the pattern. This can be used to specify multiple patterns, or if the pattern starts with dash, so here a line only has to contain one of the patterns to be matched. For example, if we type grep-e apple -e date multi-pattern, here we are looking in the multi-pattern file that every line that contains apple or date. We don't really looking for a line that contains both, but one of them should be enough to print this line. Another output control, which is the -c. So the -c will suppress normal output and instead print out a count of matching lines for each input line. So here C is for counting. So grep-c hello multi-pattern. Here it will say, or it will print how many lines we have or contains the hello word in the multi-pattern.txt file. The -i, it will suppress normal output and print the name of each file that contains at least one match. So here we are looking for banana in every file that contains file 1 or file 2. The star here will replace 1 or 0 or 1 character. For example, we can look in this pattern in the file for this pattern in file 1 or file.txt or file abc.txt or whatever. So this star will replace 0 or more characters. Now the capital L will suppress normal output. It will print the name of each line that does not contain any matches. So it's the lower L and the capital L are different. So here grep-capital L kiwi file.txt will search for the lines that does not contain the word kiwi. So here both -L, capital and lower option will stop searching a file once a match is found. Another output line prefix control. So we have -n, which is prefixes each line of output, with the line numbers from the line for the input, file the match was found on. For example, grep-n banana, we are looking for each line that contains the word banana, and -n, it will print the number of this line in this file. The -h is a prefix each line of output with the input file name that the match was found in. So, for example, we have grep-h cherry file star.txt. And then the capital T will make sure that the actual line content or whatever content comes after the -t lands on a tab stop. Means if we type grep-t date files or file star.txt, we are looking for the word date in whatever file 1, file 2, file n. And here in the output, we will make sure that we have a tabulation between the content and the name of the file and the word date. We will try all these examples, but here I'm trying to give you the tools to understand later what are these options, what they do, and how to use them. So another context, line control, A or dash A, and we give the number. If we type, for example, grep dash A1, so here it will print number lines of trailing countings after matching lines. If we type grep dash A1, so we are looking for the pattern, which is apple. So we are looking for a line that contains the word apple and one line after. If we put grep dash A2 apple, so we are looking for a line that contains the apple word, then two lines after. It will print also two lines besides the line that contains apple. Same concept for B, but it will print the lines before the matching lines. C, it is the B and A together. So if we have grep, this should be dash C, one banana. So we are printing the matching line, one line before and one line after. So C is the number of the line, or it's the merging of A and B, one line before and one line after, or two lines before and two lines after. So this is an example just with A, with B, and with C. We will try this in our command line. So let's see how to use or how we define the pattern. So we will use a wildcard. For example, the dot used as wildcard for any one character. Then the one after, which is anchor position at the start of the line. The dollar to anchor position at the end of the line. The /p to set word boundary before and or after a pattern. The question mark to search for 0 or 1 character. The plus to search one or more of characters, and the star to search 0 or more of a character. We just saw an example of file star.txt. Means we are looking for a file that has the name contain file.txt or file abc.txt or file1.txt. So this star will replace 0 when we have file.txt or 1 when we have file1.txt, so only one character, or multiple characters when we have file abcdef.txt. However, if we put file plus .txt means we need at least one character after the file word. Means we cannot accept file.txt. We should at least file a.txt or file1.txt or file abcd.txt. But at least we need one character or more after the file word. If we have the interruption question mark, means we have 0 or 1 character. Means we can have file.txt, just file without anything else, or file1.txt or file2.txt or file a.txt. But with the question mark, we cannot have file ab.txt, only 0 or 1 character. And here the brackets used to define character class sets. Let's start with the first one. So the anchor here, the first one is to mention that we are starting the line. But when it is the inside brackets, it means not, means the negation. The dollar means the end of the line. And the /p, which means the word boundary position where one side only in an ASCII letter, digit, or underscore. The brackets. So a bracket expression is a list of characters enclosed by the open bracket and the closed bracket. It matches any single character in the list. So we have a list in these brackets, and one of these, or any single character needs to be matching in this list. However, if the list character is in the list is first is character, it matches any character not in the list, means the negation. When we have this special character, means we have the negation of this one. For example, if we have in the brackets ABC, means we are looking in our file for the ABC pattern. If we type this character at the beginning of the brackets, means we are looking for a pattern that does not contain ABC. We can also use the dash in the bracket expression to express that we have March. For example, from 0 to 5. We can express it by putting 0-5, which is the same as 0, 1, 2, 3, 4, 5. So here, some ranges are predefined in character classes. So if we put the brackets with digit, it's the same as 0, 1, 2, 3, 4, 5, 6, 7, 8, and 9. Now, when using grep, the class name, including the brackets, must be contained with another set of brackets. Some examples for the character classes. So the first example, we specify that we have 3 characters, one of the characters in the bracket. So we are specifying A, E, I, O, and U. So we are looking for each line that contains one upper vowel. Now, one of the characters in the brackets means T. We are looking for T with A or O, then P. The order here is considered T first, then A or O, then P. Means we are looking for tape or top words. As we set the dash here to indicate the range indicator, so A, Z, so we are looking for one lowercase that is between A and Z, one of the characters in the range from X to Y. Here, for example, we are looking for the capital letter from A to Z, one or more times. Means we can find A, B, C, or and they should all be capitals. But here, at least one, we will find one capital character in this range. For example, grade. So, as you can see here, grade contain the A, the G, the R, the E, the A, and the D, which is one or more times of these capital letters. So here the same, here we have the negation, one character that is not X. So here we have one character or 3 times here. We will see what does curly braces means. So the first part, which is into the brackets, means that we are looking for a character that is not between A and Z, which is the negation. 3 here, the curly braces means how many times we are looking for this pattern. Here, for example, for the plus, we said that we are looking for one or more times. For this one, when we have curly braces and a number inside of this, curly braces means we want that this pattern be repeated exactly 3 times, which is here. So we have 1, 2, and 3. And as you can see here, the capital A is not part of the range between A and Z. 1 is not part of this, is not between A and Z, and the exclamation mark is also not part of the range A and to A from A to Z. So here, when we have one of the characters not in the range from X to Y. So the second part, as we said, when we have curly braces. So the curly braces is used to define the specific number of characters to search for. For example, here we are searching for one character that is repeated 3 times, exactly 3 times. Here, like we have and to say that the preceding item is matched exactly n times or 3 times. If we have a number, then comma, and that's it. This means we are looking for, or to say that the preceding item is matched n or more times, but at least n times, at least 3 times, for example. If we have this curly brace 3, comma, means we need that this item will be looked at least or matched at least 3 times or more. To say the next one, if we have curly braces, comma, then a number, this is to say that the preceding item is matched at most m times. So we can find it 0, 1, 2, 3, or m times. So here the maximum times that we want this item will be matched. Here we are expressing the minimum and the maximum when this item is matched at least n times, but not more than m times. We saw already the plus, which means 1 or more times, 3 to say exactly 3 times. Here we have two numbers, the minimum and the maximum. So 2 to 4 times here, at least 3 or more times. The star is to say that we should be there 0 or more times. For example, we are looking for A star, B star, C star. Means the A should be 0 or more times, the B should be 0 or more times, the C should be 0 or more times. And the question mark is to say that is 1 or no. Okay, let's start some comments. So we go to our virtual machine. We open the terminal. Okay, so first thing we are going to use the VI command that we just saw. We are going to add something to our files or one file. We are going to try with one file, then we are going to close it. Then we will try the grep commands. So we open the terminal to type the command VI to okay, we just need one. Okay, here we go. So first thing, we are going to try the VI command. By the way, I have these files in my parent directory. We have a file named multipattern.txt. We have a file named numbers.txt. I have a file named file1, file2, example pattern, months, multipattern, etc. Okay, let me remove this one. Just remove it. Okay, now we are going to create file new file.txt. Now we are ready to start writing. Let's say PC 254 HTF whatever PCD. Then we type colon W Q. Okay, so we type colon W Q and we press enter. So this file, if we go now here, we will find that new file created, this new file, and it has the content that we were typing in from the command line. So this is how the VI works. Now here we were using this command to create new file and put some data on it. We can use it with existing files. For example, to open the numbers.txt, we add the numbers that we want or the data that we want to add to this file. Then we type colon WU to close this, to save and close this file. Okay, so this is for the command VI. Now we will try the grep command. So we will start with the grep I dash I. Okay, we don't need to. Okay, so this is what we have in this file that we just created. It's named new file. We type BC, then 254 HETF, etc. Then we type the colon W key, then we skip the, or we close the file. Now, if we go here and you want to try the grep dot I, and let's type hello in the file examples.txt. Here's my file. Okay, it's actually example. So we have hello with capital H, hello with lower h and capital L, and hello with lower h, e, and l and o. If we type without this, ignoring the case, it will just print the last one. So I is to say that we are ignoring the cases. Now, if we type grep v, so as we mentioned, it will show lines that does not contain the pattern hello. So here, yeah, one thing I need to mention that when it is red means these are the lines that matches the pattern. If it is white, like the case here, so if we don't have any red here, so we don't have any line that matches the pattern. So as you can see here in the previous one with grep hello example.txt, the hello is the match with our pattern. When we type grep dash v hello, we don't have any red lines, so we don't have the word hello. So these are the lines that does not contain the word hello as it is with capital case, lower case. So we have hello that has the H as capital. Then we have the second example, LL, which is capital. Then here, this one doesn't contain hello. So that's why here it is printed, because it does not match with the pattern hello as it is with lower cases. Now, if you want to try grep but not with E. And here, okay, let me just grep dash E. So here, if we mention that it's E, lower E, we said that it can be with multiple patterns, either with this one or the other one. So we will now use the multi-pattern example. Okay, this is what we have in the multi-pattern example. We will check if we have the pattern apple or date. So we go here, we type either apple or date, and we specify the name in which, or the name of the file in which we are looking for this pattern. And here we go. We are finding the lines that contains the pattern apple and the pattern date, or the pattern 8 exactly. So even if we don't have a line that contain date, it will just print the lines that contain up. So one, either this one or this one. And here, when we have both, of course, we will print the lines that contains apple and the lines that contains date. Now, we'll try another one. So with one pattern, but here instead of C or if of E, we'll type the C, and here let's, for example, look for the hello world. It is finding 0 time, means our file multi-pattern doesn't contain the word hello. Now, if we look for the apple that we just saw it, this file containing 2 tabs, which is this one. Now, this is when we are using C as an option. C means we are counting the lines that matches with this pattern. Okay, another example is when we have, okay, let's try 2 things. So grep N, and we are looking for the pattern banana, and here we will specify file star.txt. Means here we want to get the number lines that contains banana in each file that has the name file.txt or file1.txt or file8.txt or file123.txt or file abc.txt. So the star here again to replace 0 or 1 characters. Let's see. So we have file1.txt that contain 2 times the word banana, file2.txt contain, or sorry, not 2 times, the number of lines. So if we open here, or let us just make cat file1.txt. So as you can see here, banana is on the second line. Same if we click over here, file 2. So we'll find that we have banana in the second line, which is expressed here, and banana in the fourth line, which is expressed here. So when we are using grep-n, it specifies the name of the file, then the number of the line in which we found this pattern, and the pattern that we are looking for. This is for the n. Let's try another option, which is the grep, but with h. With h, it will not specify the name of or the number of lines in which we have this word or this pattern banana. Now, if we type the T is with the capital T, we said that to add a tabulation between the name of the file and the pattern. if we want to have, so 2, which is the line in which we found the pattern banana, then the tabulation, then our pattern or our banana. So this is for the options that we saw it here. So the options here, I, the B, the E, etc. The C, L. Now we will see these A numbers. Okay, so we will have okay, grep minus A or dash A1. We are looking for the pattern apple in the file multi pattern.txt. Means here we are looking for the word apple and one line after. So if we put or if we open our multi-pattern file, we'll find here apple, then banana is printed. Then we have apple, then test ABC. So it will print the line that matches with our pattern and one line after. Now, if we put A2, it will print 2 lines after this apple, which is here, apple, cherry, banana and cherry, and after the second apple, we have test ABC, test BAC. This is for A. Now, if you wanna try it for B, B1, so we will print the pattern and one line before. Now, if you remember, apple here was the first line. So let's see how it will be the output. We don't have any previous line for this apple because it's in the first line, so we'll just print this line. And for apple, the second apple we have in the previous line, we have the date. So we will print the previous line if it is there. Now for C. As we said, apple doesn't have any previous line, so it will just print the after line. And for second apple, we have date as the previous line and test ABC as the next line. We can have C2 means we are looking to print the line that matches with our pattern, 2 lines before and 2 lines after. We can use cherry, for example, which is not in the first line. So cherry here will print banana, apple, 2 lines before, date, apple, 2 lines after. And for this apple, this no. So cherry will only just print the apple, banana that they are before and date, apple that they are after. We only have one cherry here. And here we go. So again, the A to say that we are the A with the number, and for example, we are specifying the number of lines that we want to print before the lines that, say it again. So if we have grep minus or dash A2 means we are looking for 2 lines before the lines that matches with our pattern. Of course, we will also print the line that matches with our pattern. If we are using B with a number, means we are printing the line that matches with our pattern and 2 lines after. C to say that we are looking for 2 lines before and 2 lines after. For example, if our number here is 2. This is for the numbers. Okay, now let's go back to, we saw these ones, we saw, okay, let's finish. Okay, before moving to this part, let's start or let's try these patterns. So we'll now use the example pattern 5, which is here. This one, no, example pattern. Okay, so first thing we will try grab a one character, the dot is replacing exactly one character, then B. Means we are looking for the lines that contain A, then one character, then B. This character can be a letter, a number, a special character, or whatever. And of course, here we need to specify the file. Okay, we found AXB, AAB. Now, if you want to try, we will use the same file and we specify the start. So we are looking for the lines that start with the word start, like this line. So here we are specifying that we are looking for lines that start with this word. Now, if we want to try the end, we will use the dollar. We specify the word then to say that it is dollar. This is the end. So as you can see here, at the end of this line, we have the word end. Means this line matches with our pattern. Now, another case is when we are using grep with the brackets. So grep, let's say here T with the brackets, A, O, A or O, sorry, then P in the same file example.txt. Oh, I forgot the second. So if we type grep T with in a bracket with A, O, means we are looking for the lines that contains T, then A, or O, then P. So if we go here to the example pattern, we find that we have tape some. Now if we put T-O-P, then T-O-O-P, T-O-O-P, and we save, then we retype the same command. So as you notice here, we have T-A-O, T-D-A-P, another word with T-O-P, but when we type T-double-O, P doesn't match, and when we have T-O-O-O, P doesn't match, because here we are looking for only A or P. Now, if we put A and we retype here the same comment, only the tab will be appeared. Why? Because even the A or the O needs to be between the T and the P. Otherwise, it will not be displayed. So this is when we have brackets. Let's say we have the same when we are using the brackets, but here instead of T, we have the brackets with A, E, I, O, U. As you can see, as I told you, these lines, when we have red, means this is what the lines are, this is what is matches with our pattern. Now, if we want to use this one, but with n, means we are looking for the number of lines that contain with the numbers. So here, 1, 2, 4. So if we go to 3, B, C, D, it doesn't contain any vowels. So it is not printed here. So it's not really, I know it's a lot of lines, but you can see that some lines are skipped. For example, line 3, because it doesn't contain any vowel. It's just the others, what it contains. So B, C, and D. The others, as you can see in red, it all contains a vowel. Okay, now if you want to type, let's type the same command, but we add the capital case. A, I, U, O, U. It will print the same thing. Now, if you want to say that, we will need to print everything that is not in this one. So BCD S. So here to say that it starts with A, E, I, O, U, capital or lower, and here to say that does not start with A or E or I, etc. Let's try it one by one. So let's try to have this one. When it start with A, E, etc. So as you can see here, the A, so here we are saying that it does not contain the A, E, I, etc., which is in red. So as you can see, B, C, D, it doesn't contain A or E or I or O or U. So here, just to make the negation. E, which is in white, match. So that's why it's in white, it's not in red. Only the red matches with this pattern, which is again the negation. Means we are looking for the lines that does not start with A, E, does not start with the vowel, capital or lower. Now, if we type the previous command, what we will get? We will get a line that doesn't start with A, B, C, D, which is here. So B, S, W, C, G. As you can see here, they should start with no vowel, which is here. So as you can see here, we don't have any vowel here. So another example, when we are using range of numbers, let's say between 1 to 6. So we are printing the lines that contain number between 1 and 6. So, and to specify the number of lines, this line contains 2, 3, 4, 5, and here 1, 1. So let's minimize the range and put it between 5 and 2. So here we have the numbers that contain between 2, so the number should be between 2, 3, 4, and 5. As you can see here, 6 is white, so it doesn't match with our pattern. If we make it more limited, so 3, 5. So as you can see here, the 2 is now white, the 6 is not white, is white. Why? Because it is not part of the range, which is 3, 5. Now, if we try, for example, it will print the number that is not part of this range. So as you can see here, 3, then the others doesn't match. Now, if we print grep with a, let's say B, then we have the range 1 to 5, then let's say W to Z, and this up. So we'll have the lines that contains A or B, or between the range 1 to 5, or something or a letter between W and Z, which is the case here. So AXB fit with the range between W and Z. Word match with the same thing. This line contain the 2, 3 is for the pattern for the range between 1 and 5. W is the same. B, because we have A or B. So we have the capital B. Then we have the capital A. Then we have 1, 1, 1, which fit in the range between 1 and 5. And then 3, 3, 3, that's also fit with the range between 1 and 5. This is some examples about when we have ranges with the brackets, when we have the start, when we have the end, when we have the negation, when we have the number of lines, when we have the count, etc. Now we will see something else. So the Perl-compatible regular expression, which expressed as PCRE versus the extended regular expression, which are the ERE. So the ERE, or the extended regular expression, is a type of regular expression syntax that extends the capabilities of basic regular expressions, the PRE, with additional features. So here it includes meta characters such as the plus, the question mark, and the pipe character to specify repetitions, alternatives, and optional patterns respectively. Respectively means the repetition for the plus, alternatives for the question mark, and optional patterns for the pipe. So this extended regular expression is enabled by default in many Unix utilities like grep, set, and AW key when used with the -e option. Today we just focus on the grep command. Now the second type, which is the Perl-compatible regular expression, which is a regular expression engine that provides a rich set of features and syntax similar to that of Perl. It includes features like look ahead, look behind, no greedy quantifiers, Unicode characters, properties, and more. So the Perl-compatible regular expression is widely used in programming languages, text processing tools, and utilities. In utilities like grep, you need to use the -p option to enable this Perl-compatible regular expression. So here we will see that the D, the lower D, the capital D, the lower S, the capital S, the lower W, and capital W are part of the Perl-compatible regular expression syntax. Means we need the -p to enable this command. The W capital and lower, the S capital and lower are also belong to the extended regular expression, the ERE. So the -e is needed for these commands for this ERE syntax construct with grep. D to set, the lower D to set that it should matches any digit character. So here we need to specify the -p before our pattern, the capital D to say that it matches any non-digit character, inverse of the lower D, the dash or the /s matches any white space character, and the capital S matches any no white space character. The W is to matches any word character, alphanumerical character, or underscore, and the capital W matches any no-word character, which is again the inverse of the lower W. Here there is some examples. So if we have the slash D means one digit from 0 to 9, but again here, since it is part of the PCRE, means we need dash P to make it enable. The W means one word character. It can be letter, digit, or underscore. The S to say that it's one piece. The D to say it's one digit that is not a digit, which is the inverse of the lower D, etc. We will try this. We'll try this example. Okay, we'll go to our command line and so here we'll be using grep. Then our pattern will be ABC. Then so okay, start X, Y, Z. The file media pattern.txt. Okay, the intention here is to look for the pattern ABC or XYZ, but we will see if this command will work or not. So if we go to that pattern.txt, what we will see is we have ABC, we have XYZ, and we have ABC, the burden XYZ. What we need here is to print the ABC, the XYZ, and the ABC XYZ in the same line. How to do it is we need to consider this var as a special character. So we need to add the dash to say that is considered as a special characters. Okay, now if we don't wanna use the slash, what else we can use? We can put without this slash, we can add that this is an extended regular expression. So instead of adding slash to consider this character as a special character, we can put E as this is an extended regular expression. So here we are enabling this as a special characters. So we have two ways. The first way is to use the slash or to use the dash E. Now, here, as we said, the capital E is to mean we are extending the regular expression, so we don't need this escape character, the slash. Now, one other way is to put or to decompose this into two characters with the lower E. So we can have the pattern ABC or either the pattern X, Y, Z, and it will give the same result as the previous one. So here we have three ways now. The first one is this escape character, the slash, or the capital E to say this it is extended regular expression, or to specify each pattern alone. Okay, so if you wanna put grep, but here with F, that's grep /F, then patterns pattern.txt. So here, F will load patterns. Oh, sorry, I forgot. So what does F need? F need two parameters or two files. The first one is that it's going to load the content of patterns.txt, which is abcxyz. Then it will load these patterns from the file, use patterns in the pattern file to search into the second file, which can be, for example, multi-pattern. Okay. So what we are doing here, grep f means we are using or we are loading the patterns from the file patterns.txt, and we will use them to search into the multi-pattern.txt. And here we go. So instead of writing grep -e then abc or xyz in the multi-pattern, we can put them in a file, save them in a file like we did here in the pattern.txt, and use them later with any file that we want to use it. This we save as many times if we want to use this pattern multiple times with different files. Okay, so let's try another thing. So when we are talking with extended regular expression and the field compatible regular expression. Now, if you wanna returning to the example grep TAO, this is what we typed earlier. With example.txt, I think. Oh, example pattern. There we go. Now, if you want to say that we want this one of these A or O be can be repeated more than once. So we said that we want to add it at least one, so we will use the A. But let's see if when we are adding the plus will work or not. It will not work. Now, if we want to add the escape character, it will work. Why? Because if we go here, we what here? So one of the characters that needs or that they are part includes, yeah, the extended regular expression. One of them is the plus. The star is not part of it. So if we have the plus or the question mark or this pipe, here we need to add to extend the regular expression. So let's try instead of adding this one, let's say it will do the same thing. So to enable this escape character and make the plus considered as a special character as is used for the pattern, we need to either add this escape character or the slash, or to add the -e. It will not be the case if you want to use the start without enabling the C, so 0 or more times. Now, if you wanna use it for one character, it will not work. Why? Because it is one of the extended. We need to enable the extended character. So again, the plus, the question mark, the pipe is part of the special character that we need to enable the extended regular expression, or we need the slash to it. Okay, another example. If we put grep A star, B star, C star with the file multi-pattern.txt. These are the files. So we want that A will be shown, the capital A will be shown 0 or more times, same for the B, same for the C. Now we can use the same one, but the C wants to be at least once. Here, it will not do the work. Why? Because if we go now, if we type the A star, B star, C plus, as we said, we need to enable. Now we will see the lines that has A 0 or more times, B 0 or more times, and C at least once. So as you can see in the previous example, for example, AB, it was shown because C can be shown or displayed 0 or more times. Means if we have a line that doesn't contain C, that's fine. If we have a line that contains only C and doesn't contain A and B, that's fine. Now it's different. Same if we put A, B, and C. So now only A, at least B1, B one time, and at least C one time. The line that fit with all these patterns, A 0 or more times, B 1 or more times, and C 1 or more times is the test A, B, C. Okay, now let's try another example. So grep, now views P with 0 to 9. We have your range and we need to specify how many times we need to express this or have this pattern using the file example pattern.txt. Okay, so we have in this file at least or exactly 2 times. Let's say only 1 time. See, here we have one of the numbers between 0 to 2 that is repeated. Now, if we say from 0 to 9, we are extending the range, and here 4 times. So we have the number. We should have a line that contains numbers between 0 and 9 exactly 4 times. As you can see here, the length here is 4. The length here is 4. The length here in red is 4. The white, as we said, to say that is not part of the pattern. Now, if you want to say 4 and more, now this line will be part. Why? Because the pattern here said that we need to have a line that contains numbers between 0 and 9 that they are repeated at least 4 times or more. So here is 3, 3, 3, 3, 3. Now matches with our pattern. So this is when we have when we have when we are using the curly braces to specify the number of times we want this character to be appeared. Now let's try another example. Pattern with the D, and here we will be using multi-pattern.txt. Okay, so here we have the lines that contains the character D. It will not match digits specifically because here the basics regular expression syntax doesn't recognize this dash D or slash D as a special construct. So it will make it work. To make it work, here we need the dash P to enable the Perl compatible regular expression. So here we need to add dash P to say that it is a digit. In the first example here, we are not specifying, and as we said, it will not match with digits because the basics here, the regular expression here doesn't really recognize this slash D as a special construct. That's why here we need to add the dash P. Okay, so now let's try it with the capital D. We said that the capital is for the negation. So we are expressing that the numbers that are not digits, which is here on the red, except the white line, which is 5896. Now, if we type it without P, we say that we don't have any line that is not that doesn't contain a digit. All lines here contains digit. So let's try it with the W, for example. And here to say it's word. Now, if we try it with the capital W, here we have a special character, which is this one, and here we have the space. That's why it will here. So if we put, let's try something. So we mentioned earlier that the W, the capital and the lower will also work without the P because it's not part of the extended regular expression, which is enabled by default in CREP. Now, let's try the S. S to say that is the capital, the white space. Now, with the capital S, it will match these lines. Okay, so what else? One thing we can try is the grep, say A, B, C, and here we set with any file that has the name of the file .txt. So we will search for this pattern ABC in every .txt file. Now, if we put what we will have here. Now it will show the list of file names that contain the pattern ABC without showing the matching line. It just say that you have the pattern ABC in the multi-pattern.txt file. You have the pattern ABC in the file patterns.txt. That's it. Now let's try with the capital L. Capital L is the reverse. So we said that the example pattern doesn't contain the pattern ABC. The example file doesn't contain the pattern ABC. File 1 and 2 doesn't contain the pattern ABC, etc. Okay, now we have another option which is R. to say that it will search recursively. So if we are looking for ABC recursively here with the R, we don't need to specify the file, the current file or the current directory. So it will show you every directory and subdirectory that contains the pattern ABC. Grab here, it's everywhere. Now, so as we said, it will search recursively the current directory, recursively searching everything else inside this directory and the current directory, etc. Now, if you want to try Kadir Tohes mkdir to create new subdirectory, I already created one, so we will create two subdirectory, sub2. So here we will use echo to say that we will look, or we will put the content of the ABC of the file of the result of the ABC in the sub2 test. So here we have already created the directory sub2. Now we will create the test2 and we will put the echo, the result of the echo, instead of displayed in the terminal, we'll put it in the test file. Now, if we put grep -r abc, we will find it also in this pattern. Where is it? Okay, so here what we just create. We create a subdirectory to test and we put this pattern ABC in the file test. So these are the commands to when we are using grep. Now, the next part is when we want to sort our data. So we can sort the files, the numbers, the months, etc. So we were using the cat command, the cat file1.txt. So consider the content of our file containing 1, 2, 3, 4, etc. Now, if you want to sort it, here, as you can see, view the sorted contents of the data file using the sort command to list items in alphabetical order. So F, then O, then T. Now, the cat command shows the file's original contents, and if we wanna interpret, or if we have a file of numbers, so when we are adding or when we are using the sort command, it will interpret the numbers as characters and not as numbers. So it will perform a standard character sort. That's why here we have the 1 before, then the 10, and we have the 10 before the 2, because the 1 of the 10 comes before of the 2. So it's here is considered or it's manipulating the file as it is characters and not numbers. So to say that it is a file of numbers, or we want to sort this data as numbers instead of characters, we need to add the option -n. And now, as you can see, it will be from when we just put sort file2.txt, it will just 1, 10, 100, etc. And when we type sort -n, it will consider it as a number and sort it in ascending order. Now, if you want to sort data, for example, months, suppose you want to sort a log file by date. This is the content of file 3, and if you want to sort it by date, we can use the -m. So when we are sorting, we can have January, February, March, April, May, June, etc. We have other parameters, like for example, the sort, the -c, and the name of the file means here it doesn't sort, but checks if the input data is already sorted and reports if not sorted. D, or the directory order, only considers blanks or alphanumeric characters, excluding special characters. -f, or ignore characters, by default sort order, capitals, letter above, lower, cases, letters, and here we have, for example, dash R to reverse the sort order. Means if we want to have a descendant order and not ascendant order, we'll use the R. Let's try these examples. So let's first get the content of pattern.txt. So this is the content. Now, if you want to sort, just will be easier to change the comment. Okay, so as you can see, we start with numbers 1, then 5, then A, then B, then C, D, T, etc. Now, if we have already a file named numbers, which contains 1, 2, 5, 1, 10, 100, etc. Now, if you want to just sort, and so let's just print the content. Cut numbers.txt. This is the original content. Now, if you want to sort it, as we said, it will consider it as characters and not numbers. That's why here we found the 10 before the 2, the 100 before the 3. Now, if you want to consider it as numbers, we will add the n. Now you can see 1, 2, 3, then 10, 100, 1, 2, 5, etc. Now we have another files containing the months. So if you want to sort based on the months, we can find January, February, March, etc. The original content of months is mixed. So it's April, May, January, etc. So one more thing here, we can just have Jan, G-A-N for January, or F-E-B for February, or like we have November, N-O-V, etc. So when we are sorting, it will know that November, N-O-V, it's for November, or yeah, that's it. So you can just type G-I-N or Feb or November or whatever. Now, if you want to have the numbers in so here to check if this file is sorted or not. What does this mean? If we type sort-c numbers.txt, we see that sort, we are looking for the numbers.txt. Means here that the file's number.txt is not sorted. Why? Because the line number 1 is out of order. So if we open the numbers, we saw that this line number 1 is disordered. So it should not be at the first line. So from here, the program or Linux can say that this file is disordered. Why? Because the first line is not in the right place. So if we put, let's say here, and we try. So it will mention that the line number 5, the 1, 2, 5 is disordered. Now, if you want to put it in reverse order, this is in reverse order. Again, here it's considered as alphabet, as characters and not as numbers. Why? Because we are not adding n. So this is about the grep, the sort, how to use the pattern matching, etc. Hope you like it. Hope it will be beneficial for you in your in the future, and see you in the next lecture.